These are the solutions to the prep set on the 26th of September, and it was addition of algebraic fractions. And question 1a said simplify a over 4 plus a over 8. The same way as you do with normal numerical fractions, you find the lowest common denominator, and in this case that's 8. And then you say, how many times does 4 go into 8? Twice. And multiply that 2 with that a up there. So that's 2a. And then we've got this add here. And then how many times does 8 go into 8? It goes once. 1 times a is a. So we get 3a over 8. Question B. X over 7 minus x over 9. This is very similar. Common denominator of 63, which is 7 times 9. 7 into 63 goes 9. 9 times x is 9x. 9 into 63 goes 7. 7 times minus x is minus 7x. 9x at the top minus 7x at the top is 2x over 63. C. P over P over 3 plus 5p over 6. That's a 3 there. Again, common denominator is 6, or the lowest common denominator is 6. 3 into 6 goes twice. 2 times p is 2p. 6 into 6 goes once. 1 times 5p is 5p. Add. 5p plus 2p is 7p divided by 6. Question 1d. 2x over 3 minus 2x over 7. Common denominator 21. 3's into 21 goes 7. 7 times 2x is 14x. 7 into 21 goes 3. 3 times 2x is 6x. We've got this minus sign here, so it's minus 6x. 14 minus 6 is 8x over 21, which is x. 8x over 21, that's as simple as that goes. Okay, E. Y minus 1 over 2 plus y plus 1 over 3. Common denominator 6. 2 into 6 goes 3 times, so multiply this y minus 1 times 3. And then we add, extend that a bit. 3 into 6 goes 2, so 2 times y plus 1. Let's just multiply these brackets out. We get 3y minus 3 plus 2y plus 2 all over 6, which is 5y minus 1 over 6. Gathering the like terms, 3y plus 2y is 5y minus 3 plus 2 is minus 1. F. (3x plus 1 over 4 plus x minus 3 over 5. Common denominator of 20. 4 into 20 goes 5. So multiply that 5 with what's at the top. 5, 3x plus 1. 5 into 20 goes 4, so multiply that 4 with that x minus 3. So that's multiplying out brackets, we get 15x here, plus a 5, plus a 4x, minus a 12, all over 20. And then we have 15x here and 4x there makes 19x. And a 5 minus 12 is minus 7. G. T minus 2 over 4 minus, and this is causing a few people some problems, that minus common denominator of 12. 4 into 12 goes 3, so multiply 3 with that t minus 2. Then we get minus. Now we need to be careful now, we need some brackets, because it's the subtraction of 3 into 12 goes 4. 4 times t plus 3. Multiply out the brackets, get 3t minus 6 minus brackets 4t plus 12 all over 12. So notice here we've still got this minus, and then we've got sorting out this inside bracket here, and it's a subtraction of all of this bracket. Quite a few of you have forgotten to put brackets there to make sure it's subtraction of all of this fraction. 3t minus 4t is minus t, and minus 6 minus 12 is minus 18. H. Two over x plus 3 plus 4 over x minus 1. Common denominator of, multiply out. If you can't find a common denominator easily, you multiply them out. So let's just multiply them out. And then you say, how many times does x plus 3 go into that common denominator? And the answer, of course, is x minus 1 times. Because, if you said over here, do this in red, x plus 3 times something is equal to x plus 3 times x minus 1, then the something is obviously x minus 1. So x plus 3 goes into that, x minus 1 times. So then you multiply that x minus 1 times the 2 here. And then add, how many times does x minus 1 go into this common denominator? The answer is x plus 3 times. So you multiply that with 4. Change back to black. So multiply out the brackets at the top. So we get 2x minus 1 plus 4x plus 12. And notice I just leave the denominator alone, not multiplying it out. A lot of people have multiplied it out, there's no need. Now we have 2x plus 4x is 6x minus 1 plus 12 is 11. Apologies, just noticed a mistake, multiplying out this bracket. 2 times x is 2x. 2 times minus 1 should be minus 2, so that should be a minus 2. And that leaves minus 2 plus 12, leaving 10. Okay, and now we go on to I. Five over z plus 2 minus 3 over z plus 3 equals common denominator. Multiply the denominators together to get a common denominator. Z plus 2 into that common denominator goes z plus 3 times. Z plus 3 times 5 is 5z plus 3. Z plus 3 into this common denominator goes z plus 2 times. So this is minus 3 lots of z plus 3. Sorry, z plus 2, beg your pardon. Multiply at the top, we get 5z plus 15 minus 3z, and be careful here, another minus 6. And just leave the denominator factorized. 5z minus 3z is 2z. 15 minus 6 is 9. That's that finished. Question 2. In fact, we'll do that on another page. Okay, question 2. A. We have z plus 2 over z plus 3 plus z plus 1 over z minus 2 equals common denominator z plus 3 times z minus 2. Z plus 3 goes into that, z minus 2 times. So multiply that z minus 2 with that z plus 2. Z minus 2 into that common denominator goes z plus 3 times. So multiply that z plus 3 times that z plus 1. So z plus 1 there. Okay, now let's multiply out the top. So we get z times z is z squared. Minus 2z, minus another 2z, minus 4, and you may have seen that as a difference of 2 squares, which is z squared minus 4, plus z times z is z squared, plus z, plus 3z, plus 3. All over, and then let's leave this factorized. Okay, now we've got z squared plus z squared is 2z squared minus 2z minus another 2z. One of those should be in a plus, so it's here z squared plus 2z minus 2z. So that should have been a plus, sorry about that. So that 2z cancels with that minus 2z there, and we're left with z plus 3z, which is 4z. Now we get minus 4 plus 3 is 7. Now that doesn't factorise anymore, so we can just leave our answer in that form. Okay, 2b. Excuse me, 2b. 2b is 3 over x squared plus 4x plus 3 plus 2 over x squared plus x minus 6. Now what we're going to do now is to see if these denominators will factorise. So let's look at this first fraction here and see if we can factorise the denominator. X and x, two numbers that multiply to give 3, get 3 and 1, and they add to give the 4x. Now the second fraction, that also factorises x and x, 3 and 2, minus and plus. Now let's add these fractions together. Now what's the common denominator this time? Well, the common denominator is going to be x plus 1 times x plus 3 times x plus 2 times x minus 3. How many times does that go into that common denominator? The answer is x plus 2 times x minus 3 times. So let's multiply that with the numerator, 3. Plus, how many times does that denominator, go into the common denominator? And the answer is x plus 1 times x plus 3 times. So multiply that with 2. Now let's multiply the numerators out. So we get 3 into, let's multiply these two together. We get x squared minus x minus 6 plus twice, that's this bit, into x squared plus 4x plus 3 all over this x plus 1, x plus 3, x plus 2, x minus 3. So how many x squareds have we got? Well, we've got 3 from here and 2 from there, so that makes 5. Lots of x squared. How many x terms? Well, we've got minus 3 there and a plus 8 there, so minus 3 plus 8 is 5 x terms. Constants, we've got minus 3 sixes, which is minus 18, plus 6 is minus 12. And that's all over x plus 1, x plus 3, x plus 2, x minus 3. Question now is, does that numerator factorise? X and x, and we're looking at factors of 12, so that could be 1 and 12, 2 and 6, 3 and 4. It turns out that if we've got minus 4 there and a 3 there, we get, just check this, 5x squared, 15x minus 4. 15 minus 4, no, that's not right, so just noticed that I made a mistake. That should be a plus here, and that should be a minus. Apologies. That should be a minus, and therefore that should be a plus, and that should have been a minus, and therefore this is 3 into x squared plus x minus 6 and therefore we've got 3x squared, 5x squared is correct, we've got plus 3x plus another 8x, which is an 11x. 11x. Easy to make mistakes on these questions, as you can see. So now it should factorise into 5x and 5x squared here, 15 minus 4 is 11, and then we get the minus 12 from there. Now that means that this x plus 3 factor can cancel with that, and we're left with 5x minus 4 over x plus 1 times x plus 2 times x minus 3. 2 part c is 4 over t squared plus 6t plus 9 minus 3 over t squared plus 3t. Let's see if we can factorise these denominators first. Factorise denominator, we get t and a t and a 3 and a 3 and a plus and a plus, and we need to subtract, and this factorises t into t plus 3, common factor of t. So now the common denominator here is, well, the lowest common denominator is t plus 3 goes into both this and this, so we don't need to write it twice. So the common denominator is t plus 3, and then there's this t here, and then there's this, or all the rest of t plus 3's. So all we're left with as a common denominator is t plus 3 squared. So now, how many times does t plus 3 times t plus 3 go into that? Well, this is t plus 3 squared, so the leftover, if you like, is t. So this goes into this t times, multiply that with t. So we get 4t minus, how many times does t times t plus 3 go into t times t plus 3 times t plus 3? Well, the answer is t plus 3 times. So we minus 3 times t plus 3. Multiply at the top, we get 4t minus 3t, and be careful, there's another minus here, minus 9 over t plus 3 squared. This is equal to, now 4t minus 3t is just t. T plus 3 squared. And that's the final answer. 2d. X over x squared minus 16 plus x minus 2 over x squared minus 5x plus 4. Now, let's see if we can do any factorisation. So we'll give ourselves some room and put the equal sign underneath here. Now let's factorise this denominator here. This is a difference of two squares, so we know we can write that as x minus 4 times x plus 4. And then this other one we're hoping factorises as well, x and x, 4 and 1, minus and minus. And now we can add the fraction together. Common denominator. X minus 4 is in both, and x plus 4 and x minus 1. So how many times does x minus 4 times x plus 4 go into that? Well, the answer is x minus 1 times. So you multiply that with that. Now, how many times does x minus 1 times x minus 4 go into that? The answer is x plus 4 times. So you multiply x plus 4 times this. Now let's multiply out the top. We get x times x, which is x squared, and we get x times minus 1, which is a minus x, plus, and then x times x is x squared, x times 4 is 4x, and minus 2 times x is minus 2x, and a minus 2 times 4 is 8. So that leaves x squared plus 2x minus 8. Leave the denominator factorised. Okay, so we're left with 2x squared plus x minus 8 over x minus 4 times x plus 4 x minus 1. Now you'll find that this doesn't factorise, so this is the final answer. 2e, 3p over p minus 2 minus 2p minus 4 over p squared. This has got a common denominator of p squared times p minus 2. And p minus 2 goes into that p squared times. We've got p squared times 3p minus, that minus there, p squared into this common denominator goes p minus 2 times, so multiply that with the numerator, we get p minus 2 times 2p minus 4. Make sure that denominator is long enough. So this is equal to, now let's multiply at the top now, so we get 3p cubed just to bear with me a second. Notice that this can factorise here, this bracket here. So let's just do that. So we've got p squared times 3p minus p minus 2, and this factorises into 2 times p minus 2. We get p squared, p minus 2. All we're left to do now is to multiply out the numerator. So this is 3p cubed minus, and we've got p squared. We've got a 2 there, so it's 2p squared. Okay, so that's the final result for that, simply multiplying out this numerator up here. I hope you realise that these are actually quite hard. these are at the upper end of what you're expected to do for GCSE. Certainly you won't get anything as difficult as this for GCSE. But for the additional work that we'll be doing in the top set, this is the sort of standard that could be expected. Even so, even this exercise goes into fairly hard levels of algebra. Let's do 2f. Okay, so we've got x squared minus 4 over 3x minus 3 times 9 over 2x minus 4. So notice that this is a times, first of all, not an add. So let's first of all try to do some factorization on these numerators and denominators. Looking at the numerator here, this is a difference of 2 squares. So that's x minus 2 times x plus 2. I'll write it down at the bottom here, give me a bit more room. X minus 2 times x plus 2. And the denominator here, that can certainly factorise. Take out 3 as a common factor. And x minus 1 multiplied by 9 over, and this denominator here factorises common factor of 2. Right, now since these are multiplied together and not added, if they were added you couldn't cancel across a plus, but you can certainly cancel across a multiplication. So this x minus 2 factor will cancel with that x minus 2 factor there. So what we're left with is 9 times x plus 2 over 6 times x minus 1. And if you wanted to, you could finalise the 9 over 6 as 3 over 2. So this is 3 x plus 2 over 2 x minus 1. To be done, let's start with 3a. X squared minus 7x plus 12 over x squared plus 3x plus 2 times x plus 1 over x minus 3. So let's do some factorisation. First of all, let's factorise this and this. So factorise that numerator and factorise that denominator and multiply that by x plus 1 over x minus 3. Some multiplication there. So my pen's gone a bit weird here. Right, so let's factorise this. We've got x and x, two numbers that multiply to give 12 and I have to give 7 of 5 and 2. And we want 2 answers. Now the denominator here, two numbers that multiply to give 2 and I add to give 3 are 2 and 1, both pluses. Okay, so now we can, because this is a multiplication and not a addition, we can, certainly we could put brackets in here if we wanted to. Well, this x plus 1 factor can cancel with that x plus 1 factor there. So we end up with x minus 2 times x minus 5 over x plus 2 times x minus 3. Okay, part 3b. X squared plus x minus 12 over x squared minus 4 times x squared plus 2x over 3x plus 12. There's a lot of factorisation. Sorry, the screen went a bit funny then. There's a lot of factorisation to be done here. So let's start off by factorising all of these separate denominators and numerators. Give you a clue as to how that second fraction factorises. I haven't done two brackets, just a single one. So let's have a look at this numerator here. Two numbers that multiply to give 12 and differ by 1 are 3 and 4. So 3 and 4, and we need a plus and a minus. X squared minus 4 is the difference of two squares. So that's x minus 2, x plus 2. This here has a common factor of x at the top. So x plus 2. And on the denominator here, there's a common factor of 3. So 3 into x plus 6. Now again, we're multiplying, so we can cancel some fractions. So let's cancel that x plus 2 factor with that x plus 2 factor there. Not much else we can cancel. So we're left with x plus 4, sorry for the red pen, x minus 3 times x over 3, x minus 2, x plus 6. Apologies, I made a mistake factorising this. Of course, that should be 3x plus 4. And in which case we can cancel that 3x plus 4, that 3x plus 4. So that would have been a 4. That cancels with that. And we end up leaving x minus 3 times 3, x minus 2. I realise I haven't been recording it for the last few minutes. I factorised all of the requisite quadratics into their product of linear factors and did some cancellation. And noted, of course, that I cannot cancel this a plus 2 with this a plus 2 because they're both on the denominator. So D (8 over x divided by 6 over x squared). Dividing fractions, you turn the second fraction upside down and multiply. And then an x can go with this x here, and 2 goes into 8 4 times, and 6 3 times. So we're left with 4x over 3. That's a nice easy one for a change. E, y minus 1 over 2 divided by x plus 1 over 3. Is y minus 1 over 2 multiplied by, turn the second one upside down and multiply. So this is 3 times y minus 1 over 2 to x plus 1. And F. S squared plus 4s plus 3 over s squared minus 16. Turn the second one upside down and multiply. So let's factorise this numerator. Sorry, I've got enough room there, so let's factorise this numerator and this denominator. 3 and a 1, plus and a plus, and difference of 2 squares, and that s plus 4 can cancel with that s plus 4, and that s plus 1 will cancel with that s plus 1. Which is of course equal to s plus 3 over s minus 4. G. B squared plus 5b plus 6 over b squared plus 6b plus 5, and I'm going to straight away turn the second one upside down and multiply. Now let's do some factorisation. Okay, this one, b and b, and 3 and 2, and plus, 1 on the bottom, b and b, and 5 and 1, and plus, and 3 is a common factor at the top, and we get b plus 1, and 2 is a common factor at the bottom, and we get b plus 3. So that cancels with that cancels with that, and we're left with b plus 2 times 3 over 2 times b plus 5. And the last question is h, which is x squared plus 8x plus 15 over x squared plus 4x minus 12. And I'm again, look at the question, it's a division. I'm going to turn the second one upside down and multiply. X squared plus 4x plus 3. So we've got lots of factorisation to do here. Okay, x and x, 3 and 5, plus and plus, x and x, 3 and 4, no, 6 and 2, 6 and 2, plus and minus, and x and x, 3 and 4, no, 6 and 2 again, 6 and 2, plus, and x and 3 and 1, and plus and plus. So, what can we cancel? We can cancel that with that. We can cancel that with that. Anything else? No. So, our final answer for this one is x plus 5 times x plus 2 over x minus 2 times x plus 1.